Okay, so today we're going to be exploring this special integral, and it isn't as simple as most people would think. Alright, so after looking at this integral, most people would try to simplify it, like this. And this is correct. And then some people will consider this, some people won't, but we have to look at the domain restrictions for this function to make it valid. So let's look here. E to the x has to be greater than 1, or e to the x has to be less than 1, but this is not possible, so we won't consider this. And let's draw e to the x. It looks something like this, and this point is 0, 1. And after we've put into this state, most people will try a secant substitution, like let e to the x equals secant theta. Well, secant, it's a very dangerous substitution, and here's why. Let's draw secant. Well, let's draw cosine first. Cosine looks like this. And this point is negative pi over 2, and this is pi over 2. Secant is just 1 over cosine, so it looks something like this. Here are vertical asymptotes. Okay, so let's look at this. E to the x is never negative, so we have to restrict the domain to only include this part. And, well, here we have a non-monotonically decreasing function, i.e. it decreases and then increases. Well, let's look at e. E doesn't do that. So we have to restrict the domain farther such that it's only increasing. So here we have to also restrict theta. And since we've restricted this, by default, x has to be greater than 0. And since we've both restricted x and theta, the integral is no longer general. And this is invalid. We can't restrict both x and theta when we're doing a substitution. So, although, the secant would look right initially, we actually can't use the secant substitution. Alright, so here's the alternative. Most people overlook this because the secant is so obvious, but here's the alternative way. We take the e to the x squared out of the square root, so that gives us since this is just 1 over e to the x squared. Alright, now, okay, we can change it a bit, and this is perfectly valid. So let's do one substitution. Let u equals e to the negative x. And well, the integral then becomes, oh wait, no. We have to do the du equals negative e to the negative x dx. And this is convenient because this term is almost equal to this term except for a negative sign, but that's fine because it's an integral. So we just put the negative sign outside, and that becomes du. And well, let's look at this. This is just 1 minus u squared, which is a very familiar integral. But, I'll do it anyways. So, we'll use a sign substitution. Oh no. Yeah. Let u equals sine theta. You could use cosine, but the integral turns really nasty really fast, so we'll use a sign substitution. Okay, so after the substitution, the integral becomes and well, the square root becomes 1 minus sine squared theta. And well, this is just cosine squared theta, and after the square root, it turns into cosine theta. And these two conveniently cancel out, which gives us, which is equal to negative theta plus c. Alright, now most of it's done. Let's undo the substitutions. Okay, well, theta is arc sine u, so and u is e to the negative x. And this is the correct answer.